Example 2. Given the graph of the function f below. Part A. List the intervals on which f is increasing. Now notice in Part B, it's asking us to list the intervals on which f is decreasing. Most of these questions will ask you to describe both regions of increasing and decreasing. So I suggest that we're going to label this graph. We're going to start at the leftmost point of the graph. We're going to trace all the way to the right and label with our pencil the areas of increasing and decreasing. So I'll start at the leftmost point here, which is negative infinity. That arrow indicates that. So as I start to move to the right, the graph is decreasing until I hit this dip, this local min, at -8, -4. So I'm going to draw a down arrow until we hit that dip in the graph, that local minimum, -8, -4. Then as I start to move to the right, the graph starts to increase. I'm going to draw an up arrow until I hit this peak in the graph at -2, 6. That's a local max. Now I'm going to draw my down arrow as I continue to the right. The graph decreases, falls until it hits 0, 0, that local min. Then it changes direction again. It starts to rise, so I'm going to put an up arrow until it hits that peak, that local max at 210. It turns around again. It starts to decrease, so I'm going to put a down arrow indicating that it's decreasing. Then I continue to the right. It increases infinitely. So now when I go to Part A and list the intervals on which it's increasing, I'm just looking for the arrows that are up. So I've got an up arrow here, I've got an up arrow here, I've got an up arrow here. So now I'll use interval notation to describe those regions. So the first region begins at -8 and it continues all the way to -2. So I can describe that as parenthesis, -8, comma, -2, close the parentheses. And again, I'm using parentheses on these areas of increasing and decreasing because at the endpoints it actually changes from increasing to decreasing, so I can't include those endpoints. My second region of increasing is here, and this region begins at an x value of 0, and it goes to an x value of 2. So I'll use parenthesis 0, comma 2. My final region of increasing is here. It begins at an x value of 5 and increases infinitely. So I can describe that as parenthesis 5, comma, infinity. Now, my intervals of decreasing. Now I'm looking on my graph here that I marked for down arrows. I've got a down arrow here, here, and here. My first region starts all the way left, which is negative infinity, and it goes all the way to -8. So my first region, I'll describe parenthesis negative infinity, comma, -8. My second region begins at an x value of -2 and goes to an x value of 0. So I describe this as parenthesis -2, comma, 0, close the parentheses. Then the final region of decreasing, it begins at 2 and it goes all the way to 5. So I describe that as parenthesis 2, comma, 5. Part C. At what number or numbers, if any, does f have a local maximum? We can see that this graph has several peaks, local maxima, peaks in the graph. So I can see that it has a peak here and a peak here. So when they're asking for at which, numbers at which or at what numbers, this is location. And we always use x values to describe location of a graph. So we want to know what are the x values at these peaks in the graph. Well, at this peak, this local max, we can see that its x value is -2. So this is at an x value of -2. And then you've got another local max here And we can see that that has an x value of positive 2. So this graph has two local maxima, one at an x value of negative 2 and one at an x value of 2. Part D wants to know what are the local maxima? What are the actual peaks in that graph? Well, local maxima or minima are always y values. So what are the y values at these two peaks? The y value here is 6 and the y value here is 10. So the local maxima are 6 and 10. Part E. At what number or numbers, if any, does f have a local minimum? We know that local minima are dips in the graph. So if we look at our graph here, we can see that we've got a dip in the graph here, here, and here. So again, we've got this at this location, so we know that's going to be x values that they're asking for. So at my first dip in the graph, the x value is negative 8. At the second dip in the graph, the x value is 0. And at the third dip in the graph, the x value is 5. So our answers here will be x equal to negative 8, x equal to 0, and x equal to 5. And then finally part F, what are the local minima? Again, these are the y values. The maxima or minima are the y values. So at this first dip, our y value is negative 4. At the second dip, our y value is 0, and the third dip has the same y value of 0. So the local minima are negative 4 and 0.